In this problem, a right angle triangle is given and this is ABC. The angle B is 90 degree. Inside this triangle we have two circles. This smaller one has a radius of 1 unit and the larger one has a radius of 4 unit. We have to find area of triangle ABC. Now to solve this problem, I will use idea of similar triangles and Pythagoras theorem. And I will also make some constructions. Now let us draw perpendicular from point P on side AB, that is PD, and on side BC, that is PE. So one perpendicular PD and this one is another perpendicular PE. This is point of contact. This means this line is tangent to this circle. Similarly, this line BC is tangent to this circle. So this is point of contact. So this means the perpendicular that I have drawn, this will pass through the point of contact. So D is the point of contact. Similarly, E is the point of contact. Because if this is the tangent and if you draw a perpendicular on this tangent, this will pass through the center. So this means this angle is 90 degree. Now this is 90, this is 90 and this is 90. This has to be 90 degree. And this is radius and this is radius. So this side and this side are equal and all angle are 90 degree. This means this is a square. So I can say PDBE, that is PDBE, this is a square. And all the sides are equal to 4 unit because radius of this circle is 4 unit and all angles are 90 degree. Now let us draw perpendicular from point Q, that is center of this circle, on PE and on BC. So I will draw a perpendicular this side and I will draw a perpendicular this side. So QT is perpendicular and QF is perpendicular. Now again, this angle is 90, this angle is 90, this is 90, this has to be 90. Now all angles are 90 degree, this means this is a rectangle. So I can say TQFE, that is TQFE is a rectangle. Now let us connect two centers, that is center P and center Q. Now if you see this triangle, this is a right angle triangle because this angle is 90, so this has to be 90 because sum of angles on a line is equals to 180 degree. Now it is important to note that this line PQ, that is connecting between two centers, will also pass through the point of contact. This is point of contact for two circles. This is because if you consider a tangent here, and on this tangent, if you draw a perpendicular, this will pass through this center. Similarly, on this tangent, this is the common tangent, draw a perpendicular this side, this will pass through the center. So perpendicular this side passes through the center, perpendicular this side passes through the center. So perpendicular plus perpendicular, this is 180 degree. This means this point, this point, this point lies on a one line. So these 3 points are collinear. Now in triangle PQT, that is this triangle, I can find various lengths. What is PT length? So PT is this length. This total length is 4 unit and this length is 1 unit because radius of circle. This is equal to this because opposite side of rectangle. So this is 1 unit. This total is 4 unit, this is 1 unit, this means this is 4 minus 1, that is 3 unit. What is length PQ? So this PQ is equals to radius of this circle plus radius of this circle. So this is 4 unit and this is 1 unit, so 4 plus 1, this is 5 unit. Now we can calculate TQ using Pythagoras theorem. So if I use Pythagoras theorem, I can write here TQ square, this is equals to PQ square minus PT square. And we know the various distances. PQ is 5, so I can plug here 5. PT is 3, so this is 3. So 5 square minus 3 square. That is 25 minus 9, which is equals to 16. This means TQ is equals to a square root 16, that is plus 4. Negative sign I cannot consider because TQ is a length and it cannot be negative. So TQ is equals to 4 unit and this TQ is also equals to EF because they are opposite sides of a rectangle. So this is 4 unit and this is also 4 unit. So let us draw QC. So this is point Q and this is point C. If you consider triangle PEC, that is this triangle, and triangle QFC, what can you say? These two triangles are similar. This is because angle PEC, that is this angle 90 degree, and angle this one, that is QFC, this is also 90 degree. So these two angles are equal. And this angle is part of this triangle, that is QCF, and the same angle is also part of this triangle, that is PCE. So these two angles are common. So this means these two triangles are similar triangles. So now I can use property of similar triangles in triangle PEC, that is this triangle, and QFC, that is this triangle. So I can write PE by QF, that is this distance divided by this distance, is equals to EC, that is this total distance divided by this distance, FC. So EC by FC. Let us say FC distance is equal to X. And other distances I know. What is PE? This is radius of the bigger circle, that is 4 unit. What is QF? Radius of a smaller circle, that is 1 unit. What is a EC? EC is this total distance, and this we have just calculated. This distance is 4 unit. 16 square minus 25 square minus 3 square, and if you take a square root of that, that is this distance, that is 4 unit. So this distance is 4 unit and this distance is x unit. So this distance is EC is 4 plus x divided by FC. FC is x unit. So from here you can calculate x is equals to 4 by 3. So now I know this distance, that is x, which is equals to 4 by 3. This I know, that is 4 unit. So basically now I know BC distance. Now this distance CM is equals to CE. If you remember, if you draw a tangent from an external point on circle, length of two tangents are equal. So this is a theorem of circle. Let us try to consider this. So for this circle, this green one, this is an external point. From this external point I have drawn one tangent, that is MC, another tangent, that is EC. Theorem says length of these two tangents are equal. This means CM is equals to CE. CM is equals to CE. But I know CE, so I can calculate CM. What is CE? This is x plus this is 4 unit. So x plus EF, and EF is 4 unit and x is 4 by 3. So this is 16 by 3. So from here to here, this length is 16 by 3. This means this length is also 16 by 3. So in triangle ABC, now I can apply Pythagoras theorem. That is AB square plus BC square, which is equals to AC square. Now what are different lengths? We have to find it out. So let us say AM is equals to by. So this is external point. From here I have one tangent on this circle I have another tangent on this circle. This means this distance is equal to this distance. AM is equals to AD, both are equal to bi. So now I can calculate distance AB. What is distance AB? This distance is bi and this is 4. So this is bi plus 4. So this is bi plus 4. So AB is known. What is BC? This is 4, this is also 4 and this is x which is equals to 4 by 3 basically. So this is 4 plus 4 8 and this is 4 by 3. So 8 plus 4 by 3. What is AC distance? This distance. This we have calculated that this distance is 16 by 3. So this is 16 by 3 plus this distance which is equals to bi. So this means this distance is 16 by 3 plus bi. And if you square all the terms, you can use the formula a plus b whole square which is equals to a square plus b square plus 2ab. Then you can expand this. So let us expand this using a plus b whole square formula. Or I can use a square minus b square formula. So let us take this 4 plus by square to the right hand side. So I will have 8 plus 4 by 3 whole square and this minus 4 plus by whole square. So this is a square minus b square which is equals to a plus b into a minus b. So let us use this formula. This is 28 by 3 whole square and this is a and this is b. So this is a plus b and this is a and this is b. So this is a minus b. So this will become minus 4 and minus bi. So in this case this bi and this bi cancels and 16 by 3 minus 4 that is 4 by 3. And here I will have 16 by 3 plus 4 that is 28 by 3 and bi plus bi that is 2 bi. So if I expand this, this is 28 by 3 and 128 I can cancel from 4. So this will be 7 and 1 3 I can cancel from this 3. So this will be only 1 3. 28 by 3 plus 2 by. And I can take this 28 by 3 this side. So this will be 7 minus 1. So this is 6 and 3. If you divide by 3, so 28 times 2. 2 by is equals to 2 times 28. So by is equals to 28. So now I know this length, that is this length. By is equals to 28. This length also known, 28. So what is AB? AB is 28 plus 4 that is 32. So these two distances are 28 unit. Now area of triangle is half times base times height. Base is BC, height is AB. BC is known, this distance is 4, this distance is 4 and this distance is 4 by 3. So 8 plus 4 by 3 and this distance is 4, this distance is 28. So 4 plus 28. So if you multiply all this, you will have 448 divided by 3. So this is the area of this triangle ABC. So I hope you enjoyed this problem, and if you like my videos, please share with your friends, like my channel and subscribe to my channel. I will see you in the next video. Thank you.